In the cold and stillness of the room, where the endless darkness reaches everywhere, there is a great man from heaven. This giant is not only the largest planet in our solar system, but also one of the most mysterious. To stand on the surface, if alive, was to face a great force, a place where everything crumbled under its weight, covered in centuries of hurricanes. But even as these storms intensify, they hide something deep and mysterious. It is powerful enough to create auroras brighter than anything seen on Earth and magnetic fields that challenge our scientific understanding. This is Jupiter, a gas giant named after the king of the Roman gods, a planet that continues to fascinate scientists and astronomers. For centuries, Jupiter has been the subject of fascination and speculation. Ancient astronomers marveled at the brightness of the night sky, and legends revolved around its dominance. However, it was only with the advent of new space exploration that people began to peel back the layers of the space giant's secrets. NASA's Juno mission, launched in 2011, has brought us closer to Jupiter than ever before. But with each new discovery, we ask more questions. What secrets are hidden in the depths of the atmosphere? Why do unexplained phenomena appear on the screen? What can this outer space teach us about our own planet and the world at large? Join us on this journey as we dive into the heart of the solar system's largest planet and uncover Jupiter's secrets, one discovery at a time. To fully understand the size and importance of Jupiter, let's start with a comparative analysis with Earth. While Earth, our blue home, is 12,700 kilometers in diameter, Jupiter is 143,000 kilometers in diameter. This large equatorial diameter makes Jupiter not only the largest planet in the solar system, but it is very large in every sense of the word. It is so large that it can fit over 1,300 floors. Despite its large size, Jupiter is composed mostly of light gases, mostly hydrogen and helium, unlike our rocky Earth. This composition means that the air giant has no solid surface, making it an alien world to us. There are many moons around Jupiter, of which 79 have been discovered so far, each with their own unique characteristics that add to the complexity and dynamics of this celestial body. After Venus, Mars and our moon, Jupiter is the fourth brightest celestial body in the night sky, its bright presence a reminder of its power in the universe. The Juno mission, launched by NASA in 2011, is a critical moment in our quest to understand Jupiter. The main goals of this mission are to probe deep into the structure of the planet and collect important data about the atmosphere, magnetic field and possible core. Named after the Roman goddess and wife of Jupiter, the space probe Juno embarks on this epic journey to uncover the mysteries of the air giant. Arriving in Jupiter's orbit in July 2016, Juno will tackle some very important research projects. At first, scientists wanted to determine whether Jupiter was really solid, a question that had puzzled astronomers for decades. In addition, the purpose of the research is to investigate the composition of Jupiter's atmosphere and understand the dynamics of its strong magnetic field. These goals are not just about educating the customer. They also contributed to the creation and development of our solar system. When Juno began its mission, it quickly returned images and data that surprised the scientific community. On September 11, 2019, Juno captured an image of Jupiter that revealed a mysterious and untold phenomenon on the planet's surface. The image shows a supermassive black hole has opened up in Jupiter's upper hemisphere, a sight that sent shockwaves through the astronomy community and beyond. The appearance of this black hole can quickly explain the great ideas. Theories ranging from the legitimate to the outlandish began to circulate on the internet, each trying to explain this strange phenomenon. Is this entrance to the other side? Is it a new storm? The imagination is endless. However, according to NASA, the reality is less likely but impressive. The dark spot on Jupiter's surface, which looks like a black hole, is always a shadow. In fact, it is the shadow cast by one of Jupiter's moons, Io, on Earth's surface. Io, one of the 4 Galilean moons discovered by Galileo Galilei in 1610, is the third largest moon of Jupiter and the most active volcano in the solar system. The scene that captured Juno's image was a solar eclipse on Jupiter, when Io came between the Sun and the gas giant, creating a shadow that resembled a black hole. Juno. Although this natural sight is less natural than previously thought, it is no less impressive. It provided a rare and beautiful view of the dynamic interaction between Jupiter and its moons. When the mystery of the so-called black hole is solved, another mystery emerges that continues to baffle scientists. This feature, called Jupiter's abyss, is captured in another set of images taken by Juno. At first glance, the abyss looks like the shadow cast by Io, but upon closer inspection it turns out to be quite the illusion. Unlike the previous shadow, this is not a simple optical illusion caused by the passage of the moon. Instead, large craters and cracks were found on Jupiter's surface, a disease that could not be easily explained. Unlike Io's shadow, this gap is not the result of a solar eclipse. This is a very obvious aspect at the client level that raised many questions. What does that structure look like on a lot of air? Is it a tornado, or something else? NASA scientists have put forward several theories, including that the crater is a gas vortex, possibly a large storm system with deep roots in Jupiter's atmosphere. However, this is only a first impression, and the true nature of the abyss is one of the most amazing things in the world of science today. The importance of these images and data collected by Juno is beyond doubt. It is of great value to the scientific community and provides a window into the complex dynamics of Jupiter's atmosphere. By studying these features, scientists hope to draw parallels to similar features on Earth. For example, the eddy-like movements seen in Jupiter's atmosphere have been compared to sea swells in the Baltic Sea on Earth. Despite the large differences in scale and environment, the underlying physical processes are similar. This theory emphasizes a fundamental truth about the universe: although the celestial bodies in the universe are different, they are governed by the same principles. Absolute sight rules. One of the most remarkable features of Jupiter revealed by the Juno mission is its large magnetic field. This magnetic field, called the magnetosphere, is not only larger and stronger than scientists previously thought, but also works in ways that are unknown to current understanding. Jupiter's magnetism is so strong that it extends millions of kilometers into space, beyond the planet. In this planet, Juno saw auroras that were much stronger and more complex than those of Earth. These auroras are caused by the interaction between charged particles from the Sun and Jupiter's magnetic field, a process similar to what happens on Earth, but on a different scale more. The discovery of these auroras has deepened the study of the nature of Jupiter's magnetic field and its source. Further complicating our understanding of Jupiter is the discovery of so-called megablitzes, massive lightning storms that occur at the planet's poles. Unlike on Earth, where lightning is mostly associated with thunderstorms in tropical and subtropical regions, Jupiter's lightning occurs near the poles. This unusual distribution is directly related to Jupiter's unique weather patterns, which, unlike Earth, do not have strong solar radiation. Instead, Jupiter's climate is driven by the planet's internal heat, created by the slow compression of its atmosphere under the influence of gravity. This internal heat drives the planet's powerful storms and helps create its magnetic field. The Juno mission has also challenged long-held suspicions about Jupiter's core. Before Juno, Jupiter was widely believed to be rocky and icy. However, Juno's measurements have called this theory into question. The data show that if Jupiter has a core, it is not a dense, solid mass as previously thought. Instead, they may be dispersed over a large part of the planet's interior. This has led to new models of Jupiter's formation and evolution that suggest the planet may have formed through a different mechanism than previously thought. Understanding the nature of Jupiter's core is essential to developing accurate models not only of Jupiter, but of the formation of other giant gases in the solar system and beyond. As Juno continues its mission, the data it collects will be valuable for future research. The findings from this mission are renewing our understanding of gas giants and their role in the solar system. By studying Jupiter, scientists hope to gain insight into the processes that govern the formation of planetary systems, both in our own solar system and in other galaxies. The mission has set the stage for the exploration of the outer planets, paving the way for new discoveries that will change our understanding of the universe. Finally, the journey to discover Jupiter's secrets is far from over. The Juno mission has given us a lot of information, but it has also raised new questions that should guide future research.